Hello and welcome to my channel. In this series, I take you through past VCAA Maths Methods exam questions and provide you with full work solutions. In today's video, we'll be going through question 9 and question 10, the multiple choice questions from the 2020 VCAA exam. So that's obviously the Calc-active exam, so you've got, guys, besides your Calc, should also have access to your notes. If you haven't already attempted these questions, then please give them a shot first before I run through the solutions. And with that being said, let's dive right in. So question 9 here. If the integral between 4 and 8 of f of x dx is equal to 5, then what is the integral between 0 to 2 of that same f of x that's got a couple of transformations? It says f of 2 x plus 2 dx is equal to. So I like to personally take a graphical approach when answering this type of question. So let's work out this new area in terms of what we already know. So this f of x, we don't know what this function looks like, but we do know that the area bounded by this function between 4 and 8 will be equal to 5. So there might be some sort of function where the area is equal to 5 here. So usually what I'll do is I'll just approximate this as a horizontal line. And since we're dealing with average values, then it doesn't actually matter what happens. So if we know that the width here that we're integrating is between 4 and 8, so that's 4 wide, then therefore the height must be equal to 1.25. So in other words, length times width is equal to 5. We know that the width is 4 there. So length times 4 is equal to 5, which would give us the length, which would be the height, which is that 1.25. So length is equal to 1.25. Great, so that's the first step when I'm answering this type of question. The second step is then applying the dilations. So we've got f of 2 here, so we know, and there's also the translation and a dilation. So hopefully you guys are familiar with your order of transformations. We need to apply that dilation first before then doing the translation. So this dilation is a factor of half from the y-axis. So we've got x and y, meaning from the y-axis, so we're going this way, left to right, it's a factor of a half. So if I was to draw that graphically, what that would then look like is that 4 becomes 2, and that 8 becomes 4. Nothing happens to the height. This height is 1.25. So we've just shrunk these values in along the x-axis. So if we're shrinking the values in, we could then work out the area of that box. So it's width 2 and height 1.25. So therefore it'd just be 1.25 times 2, which is 2.5, is the new area. Great, so that's applying the dilation, a factor half from the y-axis. The last transformation is a translation of 2 units left. So x plus 2 means we shift it 2 units to the left. So if we're doing the same thing, I'll just quickly draw it. 2 units left, this 2 here becomes 0, and this 4 here becomes 2. So we're going to have 2, it's 0, and the height stays exactly the same. So if we're moving the whole rectangle to the left, including the start and end point, then the area is not actually changing here. So that's still going to have an area of 2.5 units. So therefore, this integral, we can see 2 to 0. It's over the same region there. So that means this area of f of x, after applying these transformations, is just that 2.5. So 2.5 as a fraction is 5 on 2 for 2.5 there. So that's my preferred approach. You can do it algebraically without drawing these graphs, but I just like to draw visual representations sometimes. Moving on to question 10. So given that log of base 2 of n plus 1 is equal to x, find values of n for which x is a positive integer r, and then we've got these options here. So we can see these are all n is equal to something, and they've each got k as an element of z plus. So this you can treat as a bit of a clue. Since it's all in terms of n, well, let's just rearrange this expression and make n the subject. So we'd first convert it to the exponential form. We'd have 2 to the power of x is equal to n plus 1. Subtract 1 from both sides. So we have n is equal to 2 to the power of x minus 1. And since a very sort of crucial part of this question, it says of n for which x is a positive integer. So it's telling us that x here has to be a positive integer. And the notation for that is x is an element of z plus, where z is integers and z plus is just the positive integers. Now, if you compare our answer here to the solutions they're provided, they're very similar looking. The only difference is, instead of using x, they're now using k as the variable. So if we just apply that change to our solution, we'd have n is equal to 2 to the power of k minus 1, where k is an element of z plus. Great, so is that one of the options here? I think it should be. So it looks to me like that's option B. So this question is relatively straightforward. You might not be familiar with this style of question. It does look a little bit different, but the maths itself behind it, not too difficult. So if we look at the examiner's report for these two questions, we've got question 9. Only 35% answered it correctly, so quite poorly answered in general. And you can see they've provided an algebraic solution there. They've just sort of shown what the effect applying the dilation of factor half from the y-axis does, and then what translating 2 units to the left does not change the area, and that's how you obtain 5 on 2. Question 10. Generally answered relatively well, with 62% correctly answering B. It looks like the next highest answered solution was C, which might be a guess or for some, but others it might be the distinction between having the minus 1 in the exponential, which is what C has, whereas it should just be minus 1 outside of that exponential component there. So just minor difference in notation, or the way it's written. At a glance, it might look like the right answer. So it's really important to double check, triple check that you're circling the right one and not one that looks very similar. Great. With that being said, if you found the video useful, then please give the video a thumbs up, share it with friends or classmates. If you're new to the channel, then please subscribe for more content like this in the future. Lastly, if you've got any specific questions you'd like answered, whether that be on a school test or another past VCAA exam, then please send me an email at yourmathquestions@gmail.com, and I'll be sure to make a video so you can get the benefit from it and you can share that with friends as well. Great. So thanks for watching, guys. See you in the next one.